internal reflection, and we've looked at how to work out the critical angle using Snell's law. And in this lesson we're going to look at the uses of total internal reflection.
Good day, grade 11s. Today we will define critical angle and look at total internal reflection. We know that when light travels towards a medium with a lower refractive index, it bends away from the normal. If we increase the angle of incidence, we will reach a critical angle where the angle of refraction is 90 degrees. We can use Snell's law to calculate the critical angle. Remember, Snell's law states that n1 times sine of theta 1 equals n2 times sine of theta 2, where n1 is the refractive index of the medium in which the incident ray travels. Theta 1 is the angle of incidence. n2 is the refractive index of the second medium. And theta 2 is the angle of refraction. It is probably best to see how this works in an example. Use Snell's law to calculate the critical angle of light traveling from glass into air if the refractive index of glass is 1,52. As always, let us list our variables. n1, which is the refractive index of the glass, is 1,52. n2 is the refractive index of air, which is 1. We know that theta 2 is the critical angle, and therefore 90 degrees. Now we can substitute our variables into our equation. So 1,52 times by sine of the critical angle equals 1 times sine of 90 degrees, which means that the critical angle as light travels from glass into water is 41,14 degrees. Now let us see how total internal reflection could be useful to us. Optical fibers are very thin fibers of glass or plastic about 0,1 millimeter in diameter. These optical fibers can be used to transmit light using total internal reflection. Optical fibers are very useful because they are flexible and the light will stay inside them even if they are bent. In medicine, they can be used as an endoscope to view the inside of the body. A doctor can insert the endoscope tube down a patient's mouth and down their throat and slide it into the stomach to see if surgery is needed. Optical fibers are also very important in telecommunications. Laser light, which carries data such as telephone conversations and television signals, is transmitted through the optical cables. Optical fibers used in telecommunications have several advantages. Firstly, as you can see, they can carry large amounts of data because the same fiber can carry light of different frequencies. Optical fibers are also thin and lightweight and are not affected by the static caused by thunderstorms. So, we have not only learned how to use Snell's law to calculate the critical angle, but also why total internal reflection is also useful.
So grade 11s, I think that was very useful. It was a good revision on how to use Snell's law to work out the critical angle. Please make sure you know how to do that and go learn the uses of the total internal reflection, because it is very, very useful, especially now more so in the new modern data age.